All right, so we're going to be solving some quadratic inequalities. This is the last section of this chapter, solving quadratic inequalities. And it's really not a lot different than solving quadratic equations. Other than when we get down to our final answer, we're going to have to determine whether it's a conjunction, a disjunction. Okay. And then in this situation, where I've given you three examples here, we're going to be graphing these on a number line. All right, so let's solve it. When I want to find the zeros of a quadratic, right now we have three methods. Right? We can factor, we can complete the square, we can quadratic formula. That's how you find the zeros. Graphing probably is the easiest. And if I were to graph this first one, or factor the first one, it's an easy factor, x minus 6, x minus 2. And so the zeros are 6 and 2. So we're going to draw our number line. And you always want to tell me where 0 is, because I do want a point of reference, and I think it will help you as well. Here's 2, here's 6. We don't have to get real fancy with that. We have open circle or closed. Maybe what? Closed circles, because it could equal these numbers. Right. Now, is this going to be a conjunction or a disjunction? And how do you know?
Conjunction.
How do you know?
Because the lines connect the two dots.
There's a line that's going to connect those two? How do you know?
Oh, no.
I guess that's the question. How do you find out? I mean, how do I know if it's going to be between 2 and 6 or if it's going to be greater than 6 and less than 2? How do I know? You guys don't remember? Don't you remember when we did quadratic?
Plug a point in or something?
You plug a point in, exactly. When we did the absolute value inequalities, it was kind of the same thing. We had 2 points, and then we had to pick a point, didn't we? Right. And so let's pick a point. The easiest might be to pick 0. And you go back to the original equation, and if you put in 0 for x, well, that first term is going to be 0. Minus 8 times 0, which is 0. And then we have 12. Is 12 less than or equal to 0? No. So 0 doesn't work. But if you pick a number between 2 and 6, it will work. And values greater than 6 will not work. Remember testing those intervals. We've taken this number line and we've divided it up into 3 intervals. And nothing out here worked. If one number out here doesn't work, none of them do. We picked a number between 2 and 6. If you pick 3, 3 squared is 9. 8 minus 3 is 24, plus 12. 9 minus 24 is negative 15, plus 12 is negative 3. And that's less than 0, so it works. And if we picked a number to the right of 6, that would not work. Okay? So my solution here is all x values between 2 and 6. And we know how to write that. We can write that as a conjunction where all values of x between 2 and 6. Right? Okay, so let's take the next one. What do you think the first one, the first thing we want to do here? Second, right, exactly. Set it equal to 0. So I'm going to add x squared to both sides. And I'll put it in descending order, minus the 15x plus 50. And it's less than 0. Plus 50. And I think, if it's going to factor, that's the easiest way. And this is an easy factor. Simply x minus 10 and x minus 5. And so my values for x are 10 and 5. Here's 0. Here's 5. Here's 10. Open circle or closed? Open. And pick a point. And we can go back to this equation here. And let's plug in 6. I have 36 minus 15 times 6 plus 50. That's going to give me a negative number, which is less than 0, and it'll work. And so we have another conjunction. And I can write conjunctions as 5 is less than x and less than 10. So x is right between 5 and 10. That's an and statement. It's a conjunction. Right, the third example. I'm going to do the same thing that I did with the second one and set this equation equal to 0. So I'm going to add x squared. I have the 4x, and then I'm going to subtract 8 from each side. Greater than 0. Do you think that's going to factor? No. So it doesn't factor, so we're going to use either completing the square or quadratic formula. I think it might be easier for quadratic formula. So let's go ahead and do that. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, which is called what? The discriminant, right? And sometimes it's easier, I think, to figure out the discriminant separately. Maybe it is. I mean, it's kind of less paper, I suppose. But b squared minus 4 times 1 times c. So I have 16 plus 36. So gives 52. That's my discriminant. Over 2a. Can I break that down? Can I break 52 down at all? To what? What goes into 52? That's a perfect square. 4. 4, yeah, 4 and 13. All right, you think of a deck of cards. Okay, we have 52 cards in a deck. 4 suits, so it is divisible by 4. So I can write that as negative 4 plus or minus the square root of 4 times 13 all over 2, which is negative 4 plus or minus 2 square root of 13 over 2. And each one of these terms is divisible by 2. So I have a 1 on the bottom, which is nice. Here I have negative 2, and here I'll have 1. So my solution is negative 2 plus or minus the square root of 13, and that's what x is equal to. Okay. I'm going to draw my number line. Here's 0. Okay, so let's guess where these are at. What about the square root of 13? It's going to be somewhere between 3 and 4, right? So if I put negative 2 plus 3 point something, will that give me a positive value? Negative 2 plus 3 point something. So that has to be over to the right side here. So over here is negative 2 plus the square root of 13. And then over on the other side is going to be negative 2 minus the square root of 13, which is a negative number. And like I say, you don't have to get fancy with that. If you look at the original equation up here, I'm going to have open circles. And let's plug in a number here. What's the easiest number to plug in for x? 0. So my first term will give me 0. Plus 4 times 0 is 0. I'm left with negative 9. Is that greater than 0? No. So what you're going to find out is a lot of times these intervals alternate so that if a number out here works, the one inside will not, but the next interval will. Not always, but most times they do alternate. So this becomes a disjunction, and this becomes an or statement. So I can write this as x is less than negative 2 minus the square root of 13. And then we have to write that word or. x is greater than negative 2 plus the square root of 13. And that's your solution. Okay? So you have a few problems like that. Any questions on those 3 examples? Look to factor. If it doesn't factor, use quadratic formula to find your solutions. Determine if you have a conjunction or disjunction. And some of you may remember from doing absolute value inequalities that there is a way you can tell before you even start whether it's a conjunction or disjunction. And after doing a few of the problems, you'll pick up a pattern here, hopefully. Okay. The second type of problem we will have. Notice in this inequality, quadratic inequality, we have a y as well. We have 2 variables, x and y. So we're not going to put this on a number line. We're not going to put this on an x-axis. We're going to put this on a coordinate system. Okay? All right. What is the vertex here? 2 and 2. Okay? So I know the vertex because this is in vertex form, if you recall. So let's plot that point 2, 2. All right? Mike, does this parabola open upwards or downwards?
Down. No, up.
It's going to open up because we're going to have a positive x squared. So that parabola will open up. So we can sort of sketch it. It's going to have a normal width because we have x squared. We don't have any, my a term is not going to be greater than 1, so it's not going to be any narrower. And you can put that in your calculator, I suppose, to sketch it. All right. But now what's involved here is shading. So the question is, do I shade inside the parabola or outside the parabola? And what's the easiest number to pick here? 0, 0. Let's pick the origin. So we'll put in 0 for y. We'll put in 0 for x. And negative 2 squared is 4. 4 plus 2 is 6. Is 0 less than 6? Yes. The origin works. This point here at the origin is a solution. If one point outside the parabola works, they all work. And we can show shading this way. Okay. And I would like one of you guys tomorrow, not today, tomorrow maybe show the class. You can do your shading on the calculator. And I'm sure some of you guys already know how to do that. Okay? All right. Well, let's take a problem like the second one. A little bit different. We're going to subtract the x from each side. X squared minus x minus 6. Because I don't have a lot of graph paper, what I'm going to have you guys do is just sketch it on your own. I don't really care where the vertex is right here. Let's just get a couple of points. When x is 0, what is y going to be? Negative 6. Putting in 0 for x, y will equal negative 6. So it'll be down here. I know it's going to open upwards, Mike, because it's positive x squared. Do we know what the x-intercepts are? We kind of do if we factor it, and it's an easy factor. It's x minus 3 and x plus 2. My zeros are at 3 and -2. Remember, that's your x-intercepts. So we have at -2 and 3. Now the y-intercept, that's not your vertex. It's not right in the middle of those two numbers. What about the parabola itself? Notice anything I can do before I draw that parabola? What is it, Dalton? It opens upwards, sure. You have the 3 points. What else, though, before I draw it? Don't see anything? It's not equal to, so what do we have to do? So dotted line, very good, Jim. It's going to come down below this line a little bit. And like I say, you can put these in your graph, sort of get an idea. Label your x-intercepts. The first example I did, there was no x-intercepts. Okay, so I didn't have to label. But here, label. Do I shade inside or outside? After a while, you're going to see a pattern. We're going to take the original. I'm going to pick a point, pick the origin. 0 is greater than 0 squared minus 0 minus 6. Is that true? Is 0 greater than -6? Yes. So when I plugged in the origin, it worked, and it is inside the parabola. If one point works inside the parabola, they all do. And you can show shading that way. All right? Does that make sense? My niece Emily is actually it's 11 o'clock. So my niece Emily had an interview this morning at a high school. She had just finished her student teaching, and she's majoring in math, so she's interviewing for a math teaching position. And so they have smart boards, and so this lesson is for her, so she gets to see how we use the smart boards in case anybody's had something, go on a website and get the information. What she had to do today was she had to teach 6 students and 6 administrators how to factor a quadratic where the leading coefficient was greater than 1. Our method was, how did we do that?
Factor it out.
Well, we factored out, it was a guess, wasn't it? We guessed and checked. Okay, and she has a little chart that she uses. So I'm sure she's going to do very well. All right. So homework tonight. Pages 334, 335. We're going to do 12 through 57, every third problem. 60 through 63 all, and 66 through 70 all. All right?